Hello everyone. In our last video, we studied about arithmetic progression and the how to find the terms and how to find the sum of the terms. Today we are going to study how to solve the problem on geometric progression. First of all, we will see what is a geometric progression. A geometric progression is a number pattern. Here the numbers are not getting added or subtracted, they are getting multiplied or divided. When a particular number is multiplied by a constant number, for example, if you think of 2, 2 is multiplied by 3, 6, 3, 18, multiplied by 3. It's going on 54. I'm sorry. It's 54. So it's going like that. So when a number is getting multiplied by same number like that, 3 into 3, 2 into 3 into 3 into 3. This type of number patterns are called geometric progression. So today we are going to study about that, how to find the nth term of a geometric progression. So normally we call a geometric progression is like this. If the first term is A and the common ratio, we call the number which is multiplying or dividing is called common ratio, that is called R. So A is the first term, common ratio R. So the second term will be A times R. Third term will be A times R into R. R into R. That is AR squared. Then that multiplied by R, AR cubed, AR to the power 4, AR to the power 5. In this way it is increasing. So the first term is A, second term T2 we call second term T2 AR, third term T3 AR squared, fourth term T4 AR to the power 3. So if you look at that term and T4 and AR cube, T3 and AR squared, there is a connection. See, here 4 comes, here 3. Here 3 comes, here 2. Here 2 comes, here 1. Here 1 comes, here no R to the power 0, right? Therefore, now we can write Tn would be AR 1 less. Here 4 comes 3. Here T4, 5 is 4. T6 is 5. So Tn equal AR to the power n minus 1. So this is the general formula of the geometric progression to find the Tn. So Tn equals A into R to the power of n minus 1. I think it's clear. Always look at the progression. It's going like this: AR squared, AR cube, AR to the power 4. So Tn, that means nth term or general term n is called Tn is called AR to the power n minus 1. So this formula is the most important formula in the geometric progression. Hereafter, we are going to use this formula to find out any particular term in a geometric progression. Let's do one example now. Now, Tn is the important one. Tn equal A into R. Actually, R to the power n minus 1. Now, look at this progression. 2 into 3, 6. 6 into 3, 18. 18 into 3, 54. It goes on like this. If they ask the T7, you have to use A, R, n minus 1. Here you know a is the first term. This is called a. A is 2 into r. What is r mean? Divide the second term by first term or third term by second term. So if you divide third term by second term or second term by first term, you will get the same answer, but it's 3. So that is called common ratio r. N is 7 minus 1. So 3 to the power 6. Being 3 to the power 6 is a big number. If you want, you can find out the value of. First of all, you must not multiply. Remember, powered number is done first, then only you can multiply. If you multiply 2 and 3, it's wrong. You wouldn't get the correct answer. Therefore, first we will find the value of 3 to the power 6 is 3 into 3 into 3 into 3 into 3 into 3. 1, 2, 3, 4, 5, 6. 9. 9 into 3, 18. Into 3, 54. Sorry. 9 into 3, 27 into 3, 81. 81 into 3. 81 into 3, 243 into 3. 9. 9, 12, 3 to 4, 729. So this is 2 into 729. If you want, you can multiply this. 2 into 9, 18. 2 2s are 4 and 1, 5. 2 7s are 14. 1458. So if you keep on writing this number up to the 7th term, it will be 1458 because it is getting multiplied. So this is the way we are finding the 3 to the power 6. 3 to the power 6, 3 into 3 into 3 into 3 into 3, 3. 9, 9 into 3, 27, 3, 81 into 3, 243 into 3, 729. That is multiplied by this A. A is 2 here. You will get the answer. Most probably, if the number is very big, they will not ask you the answer in the digital way. In the powered form, you can keep like this. This answer is also okay. So now you understood how to find the nth term in a geometric progression. So you must compare the arithmetic progression and the geometric progression. In the arithmetic progression, we studied the Tn. Look at the connection between the geometric and arithmetic. Tn arithmetic progression is a plus n minus 1 into d. This is for arithmetic. Arithmetic progression Tn. But in geometric progression, Tn equal A into Rn minus 1. This is geometric. So always don't get confused with these two formulas. This is for geometric, this is for arithmetic. Here plus, here into. N minus 1 is coming here as a power. Right. That's all. So now if you know how to solve this using the formula, that's very easy. Now I write one more sequence. Look at this sequence. 1 over 16 multiply by 2, 1 over 8 multiply by 2, 1 over 4, 1 over 2, like that it goes. So here A is 1 over 16. R is, if you don't know R, I told you, divide the second term by the first term. Second term 1 over 8 divide by 1 over 16. That is 1 over 8 multiplication reciprocal. So 8 times 2. 2 into 1, 2 over 1, 2. 2 is the R. So T, if you want T10, A into R, 10 minus 1. R you know, A you know. A is 1 over 16 into R is 2, 2 to the power 9. Right. So now being 16 is the 2 to the power 9, we can write in different way, like now as being 16 is also there. 16 is a 2 to the power number. 2 to the power. So we can write 2 to the power 9 as 2 to the power 4 into 2 to the power 5, because 2 to the power 4 is 16. We know that. So now if you write 1 over 16 into 2 to the power 4 into 2 to the power 5 is 2 to the power 9. Why I split it like this mean to cut off this 16 and this. 2 to the power 4 is 16 into 2 to the power 5. 16 get cancelled. Answer is 2 to the power 5 which is 32. So 10th term will be 32. You can calculate 2 to the power 5 is 2 into 2 into 2 into 2 into 2 into 2. 2 2s are 4 2s are 8 2s are 16 2s are 32. So this is how we are having. If the number pattern is a fractional number pattern, you have to be very careful. It is not easy to find the ratio, common ratio R. So you have to divide the second term by the first term to find out the R. After finding the R, you can apply the formula and find the any term. This is how we are manipulating or operating this geometric progression. Now let's see. In a particular geometric progression, if without giving the number pattern, without giving A or common ratio of first term, they will give in between some terms. For example, look at this. 1 over 81 multiply by 3, 1 over 27 multiply by 3, 1 over 9 multiply by 3, 1 over 3 multiply 3, 1, 3, 9. It goes like that. Now I have given you the number pattern because we are going to prove an easy way. Now without giving this any term, this term and this term is given. For example, now these all are not given. Imagine these all are not given to you. You have been given only the third term, T3. T3 is given 1 over 9. T4, 5, 6, 7. T7 is given 9. So we have to find out A. First term is how much? Ratio how much? Again I tell you, now I have written the number pattern, but here I have cancelled something because the sum is going to be third term and the seventh term are given without giving the number pattern. So how to find A? We know the answer is A is 1 over 81, but we are going to find out how to find this. You know T3 means, we don't know A, first term is A, R, n minus 1. n minus 1 means 3 minus 1, that is 2. AR to the power 2 is given 1 over 9. T7, which is AR to the power 6, why 1 less, n minus 1 is 6, that is given 9. So here equation 1, equation 2, this type of equation is also some kind of simultaneous equation, whereas this is not additional, not added. Two unknowns are not added, they are multiplied. In this case, we have to divide the equation, big equation by the small equation. So we divide equation 2 by equation 1. That is AR to the power 6 upon AR to the power 2 equal 9 division 1 over 9. I didn't write like a fraction because a fraction is written under this, it will be a confusion. So I wrote in this pattern. Now we can cancel A and A. You know, when we are dividing by powered numbers, we have to subtract the index. You know, powers are subtracted. Therefore, I write the balance over here. R to the power 6 divided by R to the power 2 is R to the power 6 minus 2 equal 9. This part I am doing now here. 9 multiplication 9 over 1. 6 minus 2 is R to the power 4 is 81. You know 81 is 3 to the power 4. 3 to the power 4. So being powers are equal, base is equal. So R equal 3. Again I tell you, in this number pattern, third term and the seventh term are given. we have to find out first term how much, recommend ratio how much. For that, first we write the third term as T3, which is 1 over 9. So T3 means AR to the power 2, AR n minus 1. We know the term formula, Tn equal AR n minus 1. Therefore, T3 equal AR to the power 3 minus 1 is 2. That is 1 over 9. T7 is AR to the power 6. That is 9 given. So when we are dividing the big equation by the small equation, we will get the answer R equal 3. After finding the R, we have to apply this R in any of these equation and find the A. If you take the first equation, AR squared is 1 over 9. Here R is already given 3. So A into R to the 3 to the power 2 is 9 is 1 over 9. So if you divide by 9 both sides, A equal 1 over 9 into this reciprocal 1 over 9, A equal 1 over 81. So answer came. So this is how we have to find. Now you can check our original sequence. A is 1 over 81 correct answer and R is 3. So this is another type of question you can expect in your examinations. In a geometric progression, without giving progression, they will give you in between some terms. 2 terms would be given, and using this technique you have to find out. So I think today's video is very useful to you. I hope you will enjoy and you will learn it. We will meet in our next video how to find the sum of the terms in the geometric progression. Thank you.